Hello everyone, welcome to the solution of LeetCode problem 150 named Evaluate Reverse Polish Notation. In this problem, we are given an array of string tokens that represents an arithmetic expression in a reverse Polish notation. And here we have to evaluate the expression. After that, we have to return an integer that represents the value of the expression. Note that the valid operators are positive or addition, subtraction, multiplication, and division. Each operand may be an integer or other expression. The division between two integers always truncates into 0. There will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. And the answer and all the intermediate calculations can be represented in a 32-bit integer range. Suppose in the first example, the tokens are 2, 1, addition operation, 3, multiplication. Now, using the reverse Polish notation, the expression will be as it is plus, so we have to add 2 with 1. So 2 plus 1 here. And now, as it is a static sign or the multiplication sign, we have to multiply the addition value of 2 and 1 with the value 3. So here, the addition value of 2 and 1 will be 3. So 3 multiplied by 3 will be 9. So 9 will be the output. And in the second examples, the token are 4, 13, 5, division, and addition. Now, as it is a division operation, we have to divide the previous two elements, which is 13 divided by 5. After that, as it is a addition operation, we have to add the division value with the value 4. So here, 4 plus 13 by 5 will be 6. I hope you understood the basic concept of reverse Polish notation. Now the constraint are, the token length can be in between 1 to 10 to the power 4, and each of the token is either an operator, addition, multiplication, subtraction, or division, or an integer ranged to -200 to +200. I hope you understood the constraint. Now let's move on to the algorithm. Now we have taken the first example, which is 2, 1 plus 3 and star. And we have to evaluate the reverse Polish notation. Now, we can solve this problem by using the stack data structure. Because as if we found any of the operator, then we have to make the operation using this operator to the previous two element, right? So that's why to find the previous two element, we have to use the stack data structure. Now, suppose we have taken a stack and we have to iterate each of the element from left to right. Now, currently our element is 2. So 2 is an integer value. So we have to simply insert it into the stack. Now there is a value 1, which is integer value. So we have to insert the element 1 here. Now, in the third element, it is plus, which is an operator. That means we have to do addition operation with the last previous two element, which is 2 and 1. So here we have to remove both of the element from the stack. So the element 1 and 2 will be removed from the stack, and we have to perform the addition operation. So 1 plus 2 will be is equal to 3. Now 3 should be inserted back to the stack. So if we insert 3 here, 3 will remain the bottom element of the stack. Now we are currently at this element 3. So here 3 is an integer value. So we have to simply insert it into the stack. Now we have found the last element, which is a multiplication operator. So as it is a multiplication operator, we have to perform the multiplication operation into the two top of the stack element. So here both of the stack element is 3 and 3. So their multiplication will be 9. So at first, we have to remove the remaining element from the stack, or the 2 element from the top from the stack, and we have to insert the multiplied value, which is 9. And we have completed the iteration here. So we have seen that the top element of the stack is 9. So in this problem, we have to return the value of 9, which is the evaluated reverse Polish notation value. I hope you understood the algorithm. Now let's move on to the code. In this problem, we are given a function named eval rpn, and we are given a vector of strings named tokens. Now, we have to use a stack which stores the long value. Now, we have to iterate each of the token into the given input. And if any of the token is the operator, that means it is the additional operator, subtraction operator, multiplication operator, or division operator, that means we have to perform the operation, right? So here we have to remove the two top of the element from the stack and store them into the variable A and B. After that, if our token is positive, we have to simply insert the addition value of the two of the element. And if our token is subtraction, then we have to simply insert the subtracted value of two of the top element. Otherwise, if our token is multiplication, then we have to insert the value of the multiplied value of both of the element. Otherwise, we have to insert the divided value. Else, if our current element is not operator, that means it is an integer. So as here we have to convert it to the integer form, string to integer. So we have used stoy, and we have to insert the corresponding converted integer number into the corresponding stack. Finally, you have to return the top element from the stack. I hope you understood the algorithm and the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the token of the given input, and the space complexity is also big O of n because we are using a stack data structure to solve this problem. And in the worst case, the size of the stack can be equal to the size of the token. So here we can say that the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.